Professor Kitaev, what a good pleasure to see you here.
Thank you.
Every scientist has a curious mind. I'm sure yours as well, if not bigger, a curious mind. So what are some of the fundamental questions that are circling in your mind these days regarding your field?
There are some big questions I cannot answer and maybe cannot even contribute to the answers. There are big questions in physics, understanding the structure of the universe, quantum gravity, some fundamental questions. And in those questions, unfortunately, we don't have experimental data to support our thinking. And it's very hard to get new experimental data. There are many very smart physicists working in this area. There are questions that are more mathematical and can be answered just by building a nice theory, maybe not so well connected to the real world. In this area, I kind of feel more comfortable. I may contribute to that. I work on questions that are between physics and mathematics.
How did you find your niche, quote unquote, in this cross-discipline science interactions?
I've always loved both physics and mathematics, and I studied physics more and worked as a physicist throughout my career, but I have always been interested in mathematics, and if there are opportunities, I try to connect these two subjects. And I usually don't try to solve very popular problems, because there are people smarter than me, and they will solve this problem quickly, but I try to find problems that are interesting. They may be hard, but a little bit overlooked. And quantum computation was such a problem when I started to work on it, and I actually learned about the idea of quantum computation as an undergraduate student. I came across a book by Yuri Manin, Computable and Uncomputable. It's a book on mathematical logic. And in the introduction, he tried to make some connections between logic and more practical thing, and he mentioned quantum mechanics, which seems very complex from the mathematical point of view. Harbors some computational complexity, and he suggested that that might lead to new ways to compute just in a couple of paragraphs. And I was fascinated by that idea, and when I learned about new developments in that area, I started to work in it myself.
How do you move from one field to another field? For example, as you mentioned, quantum computation was earlier your favorite subject, and now it has already moved on to the next stage, in which more applicable stage. But for you, you already move on to another topic. Without understanding thoroughly what you are exactly doing right now, it's very hard for me to understand every details of it. Among the experiences, what are the ones that you are now thinking as the best transition to the current field that you're researching on?
I gave one example about quantum computation.
Sure.
When I started working in this field, there was the definition of quantum computing. The first idea was informal. There was no formal definition, and then people, in particular David Deutsch, based on ideas of Feynman, formulated a model of quantum computation that can be used, and it was also important to learn some computer science, computational complexity, from which I learned that different problems can be equivalent to each other, different computational problems. There are many equivalences, and using those equivalences, you're not stuck with just one definition. You can have different definitions and choose the one that is more convenient. So learning about computational models and complexity classes helped me to start working on quantum computation. And regarding my current research, I may tell you when I solve the problem.
But you know, what is the most time-consuming for you now when you are trying to solve the new problems?
Usually when you start a new problem, it's hard because you don't know where to start.
Yeah.
Like when I try to work on quantum chaos first and to make a connection between black holes and some condensed matter model in terms of their chaotic behavior. I first got some good idea, but then when I started to develop it technically, it took a while to get up to speed because I needed to learn or just to recall some computational technique.
So you talk about the frustration, right, quote unquote, when you are trying different things, different possibilities. How do you deal with those frustrations?
I get some rest and continue.
Yeah. What is the best way to rest? Have a sleep?
Yeah, have a sleep or go hiking. Oh. I like hiking.
Yeah?
Mostly to the high places, but I also like biodiversity, flowers and things like that. Just I like nature.
Is there a favorite spot near your home?
There are a few hikes. Maybe these are not my favorite hikes, but they're close to my home, so I do them often. But there are very nice hikes in Aspen, which I visit pretty often in summers.
Having said that, though, I did notice in your receptive speech, you contributed what you have learned and earned, quote unquote, academically today with your teacher. How do you see these generational, how shall I say, links among scientists like you?
It depends. Of course, you need to learn from more experienced people to start doing research. We didn't work on a joint paper, and as a young researcher, I found a new direction which I pursued with other my fellow students. But there are some general lessons I learned from my advisor, and one lesson is that I should trust mathematics. And there was one instance where I thought that things are more complicated than they actually are. Yeah. And because if you just think about the problem and use some natural ideas and intuition, you come up with a certain answer. And I thought that things are more complicated, but my advisor told me that I should just trust this basic intuition and basic things that I started first, and eventually it will work, and it did work.
But where does intuition comes from?
It's not just intuition, it's just trying to use some general idea and trust the conclusions if don't even look plausible, but in practice it's not like that. You have to check. You always check. But sometimes things that look unlikely are actually true. But you know when you have checked by other ways. You need to have other arguments to check them.
Sounds fascinating. The truth sometimes lies in the most unexpected places, sometimes, yeah? Having said that, though, I want to ask you about how would you manage to go across culture to do your academic research?
I should say that scientists in different countries have a lot in common, and they have developed their own culture, like free exchange of ideas, and honesty in the sense that we need to search for the truth rather than being satisfied with some superficial answers.
What about AI, Professor? As that is a buzzword of all, right? And also your earlier work certainly contributing to the algorithms that many people are using these days in the application process now already. So tell us more about your thoughts about where AI is and how do you see its evolution?
Well, I should say that AI right now is not connected to quantum computing. So I have no connection to this area. It might be connected in the future when we actually have quantum computers and people will try to use them for AI and they may turn out to be useful or maybe not, we don't know. But AI is affecting our life. Of course, there are many new tools, but I worry that it will have a very negative impact on our life.
Why?
Oh, because it will take our job away.
Your jobs?
My job including, and other people's jobs.
But others suggest that the most important thing is for scientists to come up with new ideas.
Yeah.
And for AI right now, it is more about, you know, big data, learning, rather than coming up with new ideas, fundamental ideas.
Right now, it's true that AI doesn't come up with new ideas very much. Although I read in games like Go, AI comes up with new strategies that people have not invented. And it's kind of new ideas. But in the future, there will be more of that. I don't know how soon it will happen, but I don't think that I'm so smart, or even people in general are so smart that they can do something that the AI cannot do. I think eventually these jobs will be taken away.
Would you like to go hiking if that happened?
I don't know. I hope I'll be retired by that time, but...
I love you, Professor. You're so kind. Okay, thank you so much for your time, and congratulations for the award. Really appreciate it.
Thank you.